Introduction. Shakti Semiconductor refers to the Shakti Processor Project, an open-source processor development initiative led by IIT Madras under the Reconfigurable Intelligent Systems Engineering (RISE) group. The project was launched in 2014 with support from the Ministry of Electronics and Information Technology (MITY) under the Digital India RISC-V initiative. The goal is to develop an indigenous microprocessor ecosystem for India, reducing dependence on foreign semiconductor technologies. The Shakti processors are based on the RISC-V instruction set architecture, ISA, which is an open-source alternative to proprietary ISAs like Intel's x86 and ARM. These processors are designed to be scalable, power-efficient, and suitable for various applications, including IoT devices, embedded systems, mobile computing, data centers, and aerospace technology. Objectives of the Shakti project. 1. Indigenous microprocessor development. To create India's own processors for security, cost reduction, and independence from foreign chip manufacturers. 2. Open source architecture. To enable global and local industries, startups, and researchers to collaborate and innovate without licensing restrictions. 3. Customizable and secure processors. To provide security-enhanced processors for defense, space, and government applications. 4. Competitiveness with global processors. To develop processors that can compete with ARM, Intel, and AMD in terms of performance and power efficiency. 5. Fabrication and self-reliance. To promote semiconductor manufacturing in India by designing chips that can be fabricated locally. Architecture and features of Shakti processors. Shakti processors follow a modular design approach, meaning different types of processors are built for different purposes. The processors are divided into 6 major classes. 1. E-class, embedded. 1. Architecture, 32-bit and 64-bit RISC-V. 2. Use case, low-power IoT devices, smart cards, embedded controllers. 3. Performance, low compute power, optimized for energy efficiency. 4. Example, used in Maushik microprocessor. 2. C-class, controller. 1. Architecture, 64-bit RISC-V. 2. Use case, mid-range embedded applications, industrial automation. 3. Performance, supports Linux, real-time operating systems. 4. Example, used in Remo processor. 3. I-class, intermediate compute. 1. Architecture, 64-bit, out-of-order execution, multi-threading. 2. Use case, general-purpose computing, mobile applications, networking. 3. Performance, high-speed execution, suitable for complex computations. 4. M-class, mobile and desktop. 1. Architecture, 64-bit, multi-core design. 2. Use case, laptops, smartphones, low-end servers. 3. Performance, designed for performance-efficient computing. 5. S-class, server. 1. Architecture, 64-bit, multi-threaded, high-performance cores. 2. Use case, enterprise servers, cloud computing, database management. 3. Performance, can handle high workloads and multi-user processing. 6. H-class, high-performance computing. 1. Architecture, 64-bit, multi-core, up to 128 cores. 2. Use case, supercomputing, AI, ML workloads, scientific research. 3. Performance, optimized for parallel processing and large-scale data handling. Key milestones in Shakti processor development. Several versions of the Shakti processors have been successfully fabricated and tested. Some of the notable milestones are: 1. Remo, C-class. 1. Fabricated at Semiconductor Laboratory, SCL, Mohali. 2. Process node, 180 nanometers. 3. Performance, used for mid-range embedded applications. 4. Significance, India's first successful indigenous RISC-V based microprocessor. 2. Rise Creek, C-class. 1. Fabricated at Intel, Oregon, 22 nanometers FinFET. 2. Performance, higher efficiency, capable of running Linux-based systems. 3. Significance, demonstrated India's ability to design processors at an advanced node. 3. Maushik, E-class. 1. Fabricated at SCL, Mohali. 2. Clock speed, 100 MHz. 3. Use case, smart cards, IoT applications. 4. Significance, an ultra-low power processor for secure and embedded applications. 4. IRIS, Aerospace Chip 2025. 1. Developed by IIT Madras and ISRO. 2. Use case, aerospace applications, command and control systems for ISRO. 3. Significance, indigenous space-grade processor, a crucial step towards self-reliance in space technology. Comparison with other processors. Challenges faced in the Shakti project. 1. Manufacturing constraints. India lacks advanced semiconductor fabrication facilities, relying on international fabs like TSMC and Intel. 2. Funding and investment. Developing processors is highly capital-intensive, requiring substantial government and industry support. 3. Ecosystem development. Unlike Intel or ARM, India's processor ecosystem lacks commercial development tools, debugging environments, and compiler optimizations. 4. Industry adoption. Competing with well-established Intel and ARM ecosystems is difficult, and Indian industries must be encouraged to use Shakti processors. Future of Shakti processors. 1. Advanced process nodes. 1. Plans to move from 180 nanometers and 22 nanometers fabrication to 7 nanometers and 5 nanometers, making the processes faster and more power efficient. 2. Iron machine learning integration. 1. Development of specialized AI, ML accelerators based on Shakti architecture. 3. Defense and secure computing. 1. Processes for secure military communication, encryption, and cyber defense applications. 4. Indian semiconductor industry growth. 1. Shakti can play a vital role in India's semiconductor manufacturing roadmap, reducing dependency on imported chips. 5. Collaboration with startups and industry. 1. Encouraging Indian startups and large firms to use Shakti-based processes in their products. Conclusion: the Shakti Processor Project is a major step towards India's semiconductor independence, enabling cost-effective, power-efficient, and secure computing solutions. With ongoing support from the Indian government, ISRO, and research institutions, Shakti has the potential to transform India's processor ecosystem and establish the country as a global leader in semiconductor design and innovation. For more details, you can visit the official website, Shakti Project.